Problem 10. Let f of x be a continuous symmetric density function of the random variable x if f is increasing for x less than k and decreasing for x greater than k, then which of the following must be true? So problem 10, we're dealing with a symmetric function that increases to k and then decreases after k. So k is clearly the mode of the function, which means it's the value that creates the highest point. So k is the mode, and the probability that we are less than k and greater than k are equal because we are symmetric. Okay? And here I use this statement because that's going to help with the next one. So if we integrate from negative infinity to k of this f, now we can change, because it's symmetric, this probability is that we're less than k, this probability is we're greater than k. So here is the third possible answer. We're integrating from k, positive infinity to k of x of f of x. But let's switch those order of integrations. That means we have to introduce a negative. So to k to infinity of negative x to f of x dx, well, that's not equal to what they supply. So though that's not a true statement. So the answer is C. Problem 11. If f of xy is equal to this density, then what is f of y given x? Okay, this is problem 11 from exam 1 of 8, and we're given a joint distribution of x and y, and we want to find the distribution of f of y given x. So first of all, let's find the marginal of x, and that means we take the joint distribution, integrate out y. I use a u substitution to come up with this, and notice the integration limits change. Integrates to this, plug in the values, we get e to the minus x. So then to plug in, to find this distribution, y given x, it's the joint which we were given divided by the marginal which we just calculated. So it's this, simplifies to this, and that's one of the answers. Number 12, in order to estimate the proportion of students in a large university who study mathematics, how large a sample should we take to ensure that our estimate will be correct within 0.05 of the true proportion with a probability of 0.95? So number 12, so problem 12, we want to estimate the proportion of students within a certain limit. So the confidence interval for P is P hat, it's our estimate of the proportions plus or minus this quantity here. So this is the error term. So to be accurate within 0.05, that means the total length of the interval is 0.1. So it's the top minus the bottom, so which ends up being just twice that. So to be within 0.05, it's actually just this error term. We want it to be 0.05. Well, we need to solve for n here. So we square both sides, solve for n, we get this. Now we don't really know what P can be, but the maximum that this can be, it's maximized when P is 1/2. So if we plug in 1/2 here, then we're ensured that we have a large enough sample size. So if we plug in 1/2, we get 384.16, which means we need a sample of 385. Questions 13 and 14 refer to this discrete random numbers, x and y, which take on the values as follows. Y can take on minus 1, 0, and 1, and x can take on minus 1, 0, and 1. So problem 13 asks, what is the expected value of y given that x is equal to minus 1? So sample exam 1, problem 13. And now this is where we use the table, the joint distribution of x and y. And we want to find the expected value of y given x equal to minus 1. Well, by definition, that means sum. So multiply y times that distribution, sum over all possible y. Well, this distribution, it can be rewritten as the joint divided by the marginal. We're still summing over all possible y. Well, let's pause and find this distribution, f of x equal minus 1. So here we want to find this, and then we introduce a variable y, but we sum over all possible y. Well, to do that, then we just, and since there's only 3 possibilities of y, minus 1, 0, and 1, we just plug those in. And we're given this joint distribution, so we just calculate them, and it's 1/3. Well, now let's go back to this function and come down here. Now there's only 3 possibilities. Or, well, we plug in 1/3, and now we're going to sum over all y, but there's only 3 possibilities, so let's just plug in each of those. So here it's minus 1, we plug it in, 0, plug it in, 1, plug it in. Well, in each case, we here we bring up, we invert and multiply, so that's the minus 3, and that is 1/2. And this is 0, so it just cancels, don't even need to do it. This 1/3 comes up as a 3, and then that is 1/18. So the answer is negative 1/3. Problem 14, what is the covariance of x and y? So problem 14 is we want to find the covariance of x and y. So by definition, this is what the covariance equals, the expected value of this difference times y minus its mean. Well, through some algebra, that can be rewritten as the expected value of x, y times their respective means. Well, let's find these means first, okay? So to do that, we need to find the probability of each of the events. Now, in the previous equation, we found f of x equal minus 1. So with the similar process that we did up there, we can find that f of 0 is 2/9, f of 1 is 4/9. We also need to do that for y. So using a similar approach, we can find these probabilities, and then that helps us in finding the mean, which is the mean of x, which is the expected value of x. So you take the possible values times the probability of obtaining that value. So those are the two, we get 1/4. And then similarly, we can find the expected value of y as minus 1/18. So now this next step is a little bit of a legwork. So the expected value of x and y is the sum over all possible x and y times the probability that we observe, of obtaining each specific x and y. So then we go through all possibilities and probabilities, and we get 1/6. So the covariance is this, so it's 1/6 minus the product of those, which we get 14 over 81. Problem 15, the bivariate density function f of x, y is defined as f of x, y equal to 1 over pi over a region of x squared plus y squared less than 1. The marginal density function f1 of x for between minus 1 and 1 is what? So sample exam 1 of 8, problem 15, we're given a bivariate density of 1 over pi over a region, a circle region. And we're asked to find the marginal distribution of f of x. So we need to integrate out y. So we need to find the limits of integration. So let's solve for y in our restriction here, and we get this. And then we have to take the square root of both sides, so that's y goes from the negative of the square root of that to the positive square root of that. So f of x is equal to our joint, and we're going to integrate out y. Well, that is just y over pi, and evaluated each of the limits. We get this, and it reduces to that. Problem 16. A least squares regression line of the form y equal kx is fitted to the observed values. If the resulting equation is y equals x over 2, and if the sum of xy is 192.8, what is the value of the sum of x squareds? So problem 16, we're in a least squares regression line setting, and we're going to set up an equation. So each observation minus its expected, which is that regression line, k times f xi squared, if we add those up, and then we find the value of k that minimizes that, that's the least squares regression line. Now, some of you will remember what the equation is for k, and I didn't, so I need to solve it. So we're going to take the derivative of L with respect to k. So the 2 times what's inside minus 1 times the probability, or times the derivative of xi in here, which is, or derivative of k, I mean, which is negative xi. Set it equal to 0, and now we need to solve. So we multiply the xi in, and we get this. Now we distribute the sum in, and we get this, and when we distribute it in here, we get sum of xi. Remember, we've set it equal to 0. We can solve for k as this equation. Well, and we should note that the second derivative of this with respect to k is 2 times the sum of the xi squareds, which is always positive. So that means that k is a minimum. We did minimize it. Well, the equation that we're given was y equal x over 2. That implies k is 1/2. But if k, we said, was this, we can plug in our known value over that, solve it for xi squared, and we get 385.6. Problem 17. X and y are jointly distributed random variables with marginal distributions as defined, respectively. If the covariance of x and y equals 0, which of the following is the joint distribution of x and y? So, sample exam 1 of 8, problem 17, we're given that x and y are jointly distributed with marginals, given. And we want to say if the covariance is 0, what's the joint distribution? So we're given the marginals, what's the joint? But note that just because the covariance is 0 doesn't mean that x and y are independent. So if x and y are independent, we could multiply those marginal distributions to come up with a joint distribution. Now, of course, this is true if x and y are normal, but we're not given that. So in general, just because the covariance is 0, we don't know they're independent, so we can't find their joint density, so it can't be determined. Problem 18. A standard die is rolled with outcomes x1, x2, x3. What is the probability that x1 is less than or equal to x2, less than or equal to x3? So problem 18 is we're given a standard die, and this is just a little crank and grind method, just, you know, find all possibilities. So we want to find the probability that x1 is less than or equal to x2, which is less than or equal to x3. So we're going to solve it in this way. The number of all possibilities, and that's going to, and then on the numerator is going to be the number of ways that we can have the x1 is less than or equal to x2, less than or equal to x3. So the denominator, of course, it's 6 cubed, which is 216, but we don't know how many ways that this event can happen. So we just go through all the possibilities. Let's let x1 equal 1, and you can find out that there's 21 ways that you can change x2 and x3 to satisfy this. And then when x1 is 2, there's 15 ways, and x3 there's 10, and all the way down to when x1 is 6, there's only one way to satisfy this, and that's they're all 6s. So if we add up the number of ways that we can have this relationship, which is 56, the answer is 56 over 216, which reduces to 7 over 27.